Okay, here we have a special integration of the form the integral of the square root of a squared minus x squared dx. This is maybe the most complicated example in the course. In this example we're looking at square root of 4 minus x squared, so a in this one would be 2. So we're going to let x equal 2 sine theta. Now let's differentiate this. dx d theta is equal to 2 cos theta. So it follows dx is equal to 2 cos theta d theta. Now let me draw a right angled triangle and consider what sine theta is. So if we let this equal theta, well, if x is 2 sine theta is x over 2. So the opposite is x, the hypotenuse is 2. Now the adjacent side here would be equal to the square root of the hypotenuse squared minus x squared. And we see this is the same as the term we have in our integration. Considering cos theta, adjacent over hypotenuse, is equal to the square root of 4 minus x squared over 2. Therefore, the square root of 4 minus x squared is equal to 2 cos theta. And this is the important result. If you learned this off, it would make this easier. Now we also have to change our limits. So if x is 2 sine theta, well, what is theta? Well, theta then would be equal to sine inverse x over 2. So considering our two limits, 2 and 0, our first limit, we'll call it theta 1, is sine inverse 2 over 2. Sine inverse of 1 is 90 degrees, or pi over 2. And our second limit, we'll call it theta 2. Well, this would be the sine inverse of 0 over 2, since 0 is our lower limit in terms of x, and sine inverse of 0 is 0. So now we can rewrite an original expression. Limit 2 is pi over 2, limit 0 is still 0. The square root of 4 minus x squared, well, that's 2 cos theta. And dx, well, that's also 2 cos theta d theta. Now let's multiply this out. 2 2's are 4, and we can use this constant outside of the integral. The limits are pi over 2 and 0. And we have cos theta by cos theta, which is cos squared theta d theta. Okay, and this is a special case. It's written up here. The rule for this is given in the log tables. So when you differentiate cos squared theta, it gives you a half theta plus sine 2 theta over 2. And the limits are pi over 2 and theta. Now put this in yellow because this is our integration itself. And now it's just working out the value of this. Now 4 halves are 2. So we sub in pi over 2 for theta. Now 2 times pi over 2 would be sine of pi. This is divided by 2. And we have sub in 0. And we get 2 zeros are 0, so that's sine 0 over 2. Now what's interesting here, of the 4 terms inside the brackets, sine of pi is 0, 0, 0, and sine of 0 is 0. So really we're just left with 2 times pi over 2, and that's equal to pi. A very nice result for a difficult question.